The section 3.2 is titled Graphing Linear Equations in Two Variables. And the two variables, again, we're going to be using x and y. X is always going to be the first coordinate, and y is the second coordinate in the ordered pair. So we're graphing linear equation in two variables. And we're going to graph them based from a couple different perspectives. The first thing we're going to do is we're going to graph by plotting points. And the principle stays the same. The points are going to be in the form x and y. X always being the first coordinate in the ordered pair, and y being the second coordinate in the ordered pair. We're going to learn how to graph linear equations and understanding the characteristics of a horizontal and vertical line. So when you understand the characteristics of these lines, you should easily know how to graph them, horizontal or vertical lines. So we'll understand those characteristics and actually what they look like. And then we'll finish up this section with graphing using the intercepts. There's two intercepts. We have the x-intercept and we have the y-intercept. And we'll be graphing using the intercept. So three fundamental components to this section, and that is just learning how to graph by plotting points, understand the characteristics of horizontal and vertical lines, and graphing using the intercepts. Now that you know how to plot points, when we start graphing, we're going to be, again, using the ordered pair x and y. X, again, is always the first coordinate. Y is the second coordinate. X is really the independent variable here. So this is an independent variable. And y is the dependent variable. So the independent variable, x is basically our input, and that's going to be dependent on our, or whatever we put in our input is going to be based on our dependent variable, and our dependent variable y is just called our output. And one other thing, when we're going to be graphing these linear equations, I want to make sure that you make a note. The standard form of an equation of a line. You should take good notes here. You want to make sure you want to know the standard form of an equation of a line. So this is the equation of a line. And that equation in standard form is ax plus by equals c. And I want to make sure that you make a note of that a and b both cannot be 0. All right, so a and b, both of them cannot be 0. And I want to make sure you know that a, b, and c are real numbers. And again, a and b, one of them can be 0, but not both. A and b can be 0. So let's start looking at graphing equations by plotting points. So I will be looking at going over a few of the examples from 3.2 using the workbook. And this workbook examples are on Blackboard under the course content link 3.2. So we have 3 examples here. And in the lecture before, I kind of went over this little part here. So you can put the recording on pause and read that if you like. But I'm going to be working these three examples, number 1, number 5, and number 10. The direction says to complete the table and graph the corresponding ordered pair. So basically, we're completing these tables and we're graphing by plotting points. In the example number 1, they gave us the X values. So we're going to use these values for X to substitute it in for X to get Y, and then plot the points to see what the graph is going to be. Then on number 5, they gave us 2 X values that we'll substitute. And then they gave us 1 Y value that we'll substitute to find X. We'll substitute these X values to find Y. But if we look at number 10, they didn't give us any values here. So we can choose our value. We can choose our points. And the points that we're going to use are going to be very nice. We're going to use 0 and very small numbers, 1. So here in 1 and 5, they gave us points to plot. And then in number 10, we are going to choose our own points to plot. So the first example, complete the table and graph the corresponding ordered pairs. So we're going to complete the table and then graph the corresponding ordered pairs. And number 1, y equals negative 2/3 x plus 3. They're giving us the x values here, and we have to solve for y, and then we're going to plot the points. I'm going to use this space over here. We have y equals negative 2/3 x plus 3. And basically, we're just going to use these variables here or use these points here that they're giving us for x for our independent variables or our independent coordinates, and then we're going to solve for y. So the first one, x is 3. So we're just going to take this equation, y equals negative 2/3 times 3 plus 3. So they give us the x value. We're going to solve for y. So here we have y equals, the 3's cancel here. So we have negative 2 plus 3. Y equals 1. So that means when x is 3, y is 1. Then we're going to look at the second coordinate that they gave us, negative 3. So again, using exactly the same equation, y minus 2, y equals a negative 2/3. X now is negative 3 plus 3. Again, this is like 3/1, and these 3's can cancel. We have 2 negative numbers here, so that make it a positive. Those 2 negative numbers makes it a positive. So we have y equals 2 plus 3, and here y equals 5. So when x is negative 3, y is 5. And if we look at the very last x value, they have here that x equals 0. And we should be able to handle this pretty easily. So when x is 0 here, we have y equals negative 2/3 times 0 plus 3. And of course, 0 cancels here, so y equals 3. So when x is 0, y is 3. And now we're just going to plot those points there. We're going to plot those points. I'm going to make it a little bit bigger so we can see. We're going to plot the, So So we're going to plot these points. Again, this is our X and Y axis here. We're going to plot the point 3, 1. So when we plot 3, 1, again, starting at your origin, you're going to go to the right, 1, 2, 3 units, and up 1. So this is the point 3, 1. And we're plotting linear equations in this section, and all of our lines are going to be straight lines. So if you ever get a line that's not a straight line, you should check your algebra. Something's going wrong. All the lines in this section will be straight lines, linear equations, which are straight lines. Let's plot the point -3, 5. Again, starting at your origin, you're going to go to the left 1, 2, 3 units. The y coordinate is 5, so we're going to go up 1, 2, 3, 4, 5 is here. So this is the point -3, 5. And we talked a lot about this point 0. You know this is going to be on the line because you have a coordinate to 0. And it's going to be the x coordinate is 0, so y is going to be 3 on the y-axis. And this point right here is called the intercept, and we'll be talking about that more. But this is the okay. So I'm not. Let's see if we can get a point there. 0, 3. So this is 0, 3. Maybe I won't try to make this big. But more importantly, you can clearly see that this is a straight line. So this is a line. It's supposed to be a straight line. My marker is not very straight, but it is a straight line, and that's a linear equation. And that line represents the equation y equals -2/3 x plus 3. So basically, we graph this line by just plotting these points. And that's our objective for that one. Let's look at number 5. So if we look at number 5, we have 3x equals 1 plus 4y. So let's just start with the 1 first. So we have the equation. Three x equals 1 plus 4y. And here they tell us that, let's go with y equals -1. So we're just going to substitute -1 in for y. So we have 3x equals 1 plus 4 times the -1. Again, making sure we put that in parentheses to indicate multiplication. And then we have 3x equals 1 minus 4, multiplying here. And then 3x equals -1, solving for the coefficient x. So x here equals -1/3. Okay, so I've got a little error here. You see the error here? This is -4 plus 1 is 3. It's not 1. So let's see if we can erase this. So you have 1 minus 4 is -3. So when we divide by the same sign coefficient, x is going to equal -1. So when y is -1, x is also -1. Okay, using exactly the same equation, this time they let x equals 3. So the author is giving us these points. So when x equals 3, we're going to substitute in for x here. So we're going to have 3 times 3 equals 1 plus 4y. Then we have 9 equals 1 plus 4y. Now we're solving a linear equation. We're subtracting 1 from both sides. So we have 8 equals 4y. And we're solving for y, so we're dividing by the same sign coefficient here. So here y equals 2. So when x is 3, y is going to equal 2. Again, using the same equation, 3x plus 3x equals 1 plus 4y. And now we're going to let x equals -5. So wherever x is where we're going to do the substitution. We have 3 times -5 equals 1 plus 4y. This is a negative number, so this becomes -15 equals 1 plus 4y. Subtracting 1 from both sides. So 4y is going to equal -16. Dividing by the same sign coefficient here. Y is going to equal -4. So when x is -5, y is -4. So we have completed the table of values. Now let's see if we can plot the points. When x is -1, y is -1. So we're plotting the point -1, -1. It's about here. When x is 3, y is 2. So we're plotting the point 1, 2, 3, 2. This is another point that's going to be on the line. When x is -5, y is -4. So when x is -5 to the left 5 units, y is -4. Going down to 4 units. And again now, we're applying linear equations and all these should be lines, straight lines. So let's see if I can get it a little bit straighter this time. I'm missing the points. All right, so I may be missing the points, but I'm hoping that you see the objective here. Maybe I should use a straight edge. But that's a straight line. So this line represents the equation 3x equals 1 plus 4y. And next we're going to be talking about slopes. So I just want you to know that if it's rising to the right, this is a positive slope. So I'm just throwing that in as we get to slopes. Okay, when we look at number 10, this equation, -4x plus 3y equals 12. For me, whenever you have a choice, if you're going to choose, you can always choose 0. You can choose 0 for x, and you can choose 0 for y. Why do we choose 0? Because they're easy. They're easy to work with. That's all. So we can choose 0 for y and 0 for x. And so we are choosing these numbers. And because I know that, and then the other number that I'm going to choose is going to be some number that I'm almost doing some pre-mathematics to kind of figure out the solution, because I want it to be a whole number. And the reason why I want it to be a whole number, it doesn't have to be a whole number. The solution doesn't have to be a whole number, but I know that we're on the computer. And when you do these problems on Educo, I think that they only accept whole numbers. So I know 0 is going to be really nicely as I look at this. And then if I look at something that has a quantity that divides by, maybe we'll let x equals -6. All right, so I'm strategically choosing these numbers, and I'm like almost looking ahead to see what the final solution is going to be. Because when I take this equation, negative 4 plus negative 4x plus 3y. Negative, negative, oh, that's too small. Negative 4x plus 3y equals 12. So when we let y equal 0, we can almost do this almost in our head, maybe. All right. So when we let y equal 0, so when y is 0 here, then we have negative 4x equals 12 divided by the same sign coefficient divided by negative 4. So here x equals negative 3. So when y is 0, x is negative 3. So again, we are making up these numbers. So here, then let x equals 0. And again, the reason why I'm using 0 is because it's just easy to use. So when x is 0, we have this equation negative 4x plus 3y equals 12. This time we're letting x equal 0. So that means we have negative 4 times 0 plus 3y equals 12. And 0 is really nice to work with. So we have 3y equals 12 divided by the same sign coefficient. So y equals 4. And I'm using this division, meaning that I'm dividing both sides by 3. I'm using a little shortcut here. So y equals 4. So when x is 0, y is 4. Now let x equal 6. So now we are going to take the same equation and let x equals negative 6. And again now, remember we chose these numbers. And the reason why I chose these numbers is because I'm looking to make sure all right, so when x is negative 6, we have negative 4 times negative 6 plus 3y equals 12. So then we have 24 plus 3y equals 12. Subtracting 24 from both sides. Again, now we're solving the linear equation. We have 3y equals negative 12. Divided both sides by the same sign coefficient, y equals negative 4. So when x equals 6, y is negative 4. And then we're just going to plot these points here. Again, these points 0, I want you to pay attention to whenever you have an ordered pair and 0 is one of the ordered pairs, you know it's going to be directly on the line. So when we plot the point 0, when we plot the point negative 3, 0, again, starting here in the origin, negative 1, 2, 3, the y coordinates is 0. So that means that it's directly on the line. And then 0, negative 4, again, we're going to start here with 0, and then we're going to go up 1, 2, 3, 4. So this point is 0, 4. And then we have negative 6, negative 4. Negative 6 to the left and then -4. Under normal circumstances, I probably wouldn't have chosen a larger number like -6. I usually choose numbers like 1 and 2, but because of the nature of this problem, I was just strategically trying to use a number with a whole number. And this is a little bit off here. This is -5, so let me go over one more here. This is -6. Make sure it negative, then go down -1, 2, 3, 4. And one of the reasons why I kind of looked at it because it wasn't looking like a straight line. And remember, all the lines that we're graphing in this section is going to be straight lines. So let me see if I can get this through the points here. So this is the line that represents the equation -4x plus 3y equals 12. And again, now we haven't started talking about the slope, but I'm just going to go in and tell you that this is a positive slope. And that's one thing that you want to be looking at. This is a positive slope. So just know when the line is rising to the right, it's a positive slope. We'll be talking about slope in the next section. Okay, so now we are on to horizontal and vertical lines. Horizontal and vertical lines here. And you can take a moment, pause, and read this here. But primarily, I want to make sure that you understand what a horizontal and a vertical line is. A vertical line, you see the line that goes up and down. You can kind of think of it like vertical lines. And this is where the constant x is a constant. So x is going to equal something. So whenever you, now you can start or getting ready to start thinking about your patterns, vertical lines. You know that when it's a vertical line, x is going to equal some constant. Some constant, they just put a here, or x is going to be equal some constant. And here, y is a horizontal line. So whenever you see anything that y equals something, y equals some constant, you know, I just say C is a constant, means that it's not going to change. So if we were to look at the equation on these, let's just look at the equation on here. This point right here, this is 1, 2. So maybe this is like 2.5. So the equation of this line, is x equals 2.5. Let's look at the equation because you're going to be given these lines and have to figure out the equation. So if we look at the equation here, it crosses the y-axis. So this is maybe 1, 2, 3, maybe 3.5. So here, the equation of this line is going to be y equals 3.5. I'm just using my estimate. So again, now, just re-emphasizing the vertical line, you want to be very sure that when x equals some constant, your line is going to be vertical. And when y equals some constant, your line is going to be horizontal. And that's the characteristics that you want to kind of be familiar with as we continue to graph linear equations. All right, so let's look at these two examples here. Again, we're graphing linear equation, and now we're looking at the characteristics for horizontal and vertical lines. And one of the characteristics of the horizontal and vertical line is that there's only one variable here. You see, there's only one variable in this equation x, and there's only one variable in this equation y. So this is example 3 and example 2. So when you have equations where you only have one variable, you have to solve for that variable. So if we take this equation here, x plus 3 equals 0, and we solve for x. So we're going to subtract 3 from both sides. So here x equals -3. And you see x is a constant here. X is -3. So that means that all the variables of x are going to be -3. All the variables of x is going to be -3. And if you remember what I just said, and that is whenever x is a constant, even before we graph it, we should kind of start becoming familiar with what kind of line it's going to be. So when x is constant, that means this is going to be a vertical line. So let's just plot the points to verify it. When we plot -3, 0, we're going to start here. We're going to the left. We go 1, 2, 3. So -3, 0 is going to be right there. I'm trying to do it with a little marker here. -3, -3, -2. Again, starting at the origin, we're going to go over to the left, -3, and down -2. And then -3, 2. In the origin, going to the left, -3, and then 2. And you should kind of be able to see that this is going to be a vertical line. So this is the equation. This is the line, the linear, the graph of the line that represents the equation x equals -3. And you want to start kind of getting familiar with it, because later on they're going to be giving you the graph and you have to figure out the equation. Or they may give you the equation and you have to figure out the graph. So you want to start making those connections right now. Right, let's look at number 2. 2y plus 6 equals 0. Again, now they're giving you the x values, but you know that there's only one. You know that once you solve for y, you're going to have a constant here. So when y is constant, this is going to be a horizontal line. When y is constant, you're going to be a horizontal line. So start taking some good notes that you can start referring back to. And you have to solve this equation. So whenever you have an equation that only has one variable, you have to solve for that variable. So we have 2y plus 6 equals 0. If we subtract 6 from both sides, we have 2y equals -6, and divided by the same sign coefficient. So that means that y is always -3, always -3, because it's constant. So when x is -3, y is -3. When x is 1, y is -3. And when x is 3, y is -3. So again, now for my lesson, we know that it's going to be a horizontal line, but again, we're going to plot the points for verification. We're going to plot the point -3, -3. Again, here, you're going to the, starting here, going to the left, -3, and down -3 on the y-axis. So this is one point here. 1, -3. Starting at the origin, you're going to the right one and then down -3. 3, -3. Starting at the origin, you go to the right 3 and down -3. And as you can see, we have verified this is a horizontal line. My lines are not very horizontal, but you can see that it goes straight through the line, straight through the point y equals -3. All right, so this is the equation of a line, y equals -3. So you want to get very familiar with the characteristics of a horizontal and vertical line, meaning that either x is constant, which is a vertical line, or y is constant, which is a horizontal line. Okay, our last concept is, again, still graphing linear equations, and this time we're going to use the intercepts. And let's talk about the intercepts. The intercepts is exactly, if you look at this coordinate here, the intercept is where the line crosses the x and y axis. So let's just look at this one. So this line right here, this point right here, this is the y intercept. And it's called the y-intercept because that's where it intercepts the y-axis. And whatever this point is for y, we know that x is 0. So we don't know what y is because there's no numbers. We don't know how it is, but we know that x is 0. This point right here, this is the x-intercept because this is where it intercepts the x-axis, and where the intercept the x-axis, that means that y is always 0. So you can kind of think about it like in opposite forms if you want to think about it or memorize it. Here's the y-intercept. It's always where x is 0, and the x-intercept is always for y equals 0. Okay, let's look at this illustration here. The illustration that they have here, find the x and y intercepts of the graphs on the right. Complete the table below. All right, so let's just see if we can find them. We have 4 lines here. Let's look at line 1. They want you to identify the x-intercept and the y-intercept. So if we look at line 1, this is the blue line here. We're looking for the x-intercept and the y-intercept. Okay, if we look at line 1, here's your x-axis here. Let me make sure that we can see our x and y-axis here. Our x-axis is here. Our y-axis is here. So I'm gonna make sure that we clearly know where our axes are. Again, this is a problem from the workbook. So let's look at line 1. The x-axis on line 1, the x-intercept. The x-intercept, this is the first intercept here. This is the origin here. You just put a point there so you know that's the origin, right in the middle. So this is intercepting line 1, is intercepting the x-axis right here. So that's at point 1. So the x-intercept is going to be 1, 0. Because you go over 1, it's on the line. The y-intercept here for line 1, the y-intercept, this is 1, 2, 3. This looks like 0, 3. And let's look at line 2. This is line 2 here. We're looking at the x and the y-intercept, and all we're doing is looking at where it crosses the y-axis and where it crosses the x-axis. So these are not whole numbers. So we're just going to guess here. I think that it's not quite half. So we'll say this is negative 1 3/4. Say negative 1 3, 1.75. That's what I'm going to guess. We're just kind of estimating here. So on line 2, we're going to say that this is maybe 2 3/4. So the x-intercept, is where line 2 crosses the x-axis. So the x is going to be, we're going to say that it's 2.75, and y is 0. And the y-intercept for this line 2 is a negative 1.75, negative 1.75, and the x. Okay, hold on. That's all right. Eraser. So we're going down first, so you want to be careful. We're going down first. Down is the y-axis here. This is a comma here. We'll make sure this is a comma. All right. So again, we're looking at line 2. We're looking at the y-intercept. on line 2. This is line 2 here. We're looking at the y-intercept. The y-intercept okay, so the x-intercept where it's across the x-axis, the y-intercept is where it crosses the y-axis. We're looking at line 2, the y-intercept. So the y-intercept, starting here, the x value is 0. The x value is 0. And the y value, we were going down, I think we said that was 1.75. All right, let's look at line 3. Oh, let's look at line 3. What do you think about line 3? Line 3 is a vertical line. Line 3 is a vertical line. So check it out. Line 3 is a vertical line and it crosses the x-axis, and this is 0, 1, -2, -3. So that's maybe -2.5. A vertical line. We're looking at the intercept of a vertical line, and that is a -2.5. 0. This is a comma.